Can continue.
So what is the genetic algorithm? So we will see genetic algorithm in the next demo. The genetic algorithm is a method for solving both constraint or unconstrained optimization problems using genetic algorithm. Either you have a constraint or you don't have constraint. Still you can use the genetic algorithm. First thing, that is based on natural selection, the process that drives biological evolution. So we'll discuss what is the biological evolution in this case, right? So how it works, at each step the genetic algorithm selects individuals will be what? They will be your parents at random from the current population to be parents and uses them to produce the children for the next generation. Now the question is that how parents will be selected. So there are three ways we will discuss that how parents will be selected, and from the parents how children are going in the next iteration or in the next generation. Okay. So the genetic algorithm uses three main types of rules at each step to create the next generation from the current population. So how it create the next generation? See here. Selection rules select the individuals called parents, as I told, that contribute to the population at the next generation. So we require children from the parents first thing. Okay, so another is, in this case this is called elite. If a parent is becoming a children, means that he is a immortal, the parent is immortal, means parent itself will be a children in the next generation, that is they are called elite. Okay. Second is crossover rules combine two parents to form a children for the next generation. So in this case, whatever parents points we will have, we will modify it and will create a next generation. Two parents we take in this case, that is called crossover. Third way to select the next generation based on the mutation. So we apply the mutation rule. So this is the random changes in the individual parents. So mutation will work in the individual parents. Okay. Now terminology of that genetic algorithm. The fitness function. What is the fitness function? Because based on the fitness function, we select the parents. The fitness function is the function you want to optimize. So whatever your optimization problem is that will be a fitness function. Okay. For standard optimization algorithm, this is known as the objective function. Previously we used the objective function to minimize the cost of the plant. That equation will be a fitness function for the this genetic algorithm. Okay. Okay. Next, what are individuals? An individual is any point to which you can apply the fitness function. Means whatever points we have. Let's say I have three parameters here. So for one parent or for one individual, 3 points we will have. We will substitute these 3 points here and we will find out the fitness function of that. How much a parent is fit. Based on that, we create a children. The value of the fitness function for an individual is its score. For example, if the fitness function is this, the vector of one parent is this, whose length is the number of variables in the problem. We got here 3 variables we have, x1, x2, x3, 3 points we have, right? Is an individual, the score of the individual will be f and 3 points. Just substitute this and this is the fitness value for the 1 point. An individual is sometimes referred to as a genome and the vectors entries of an individual as genes. Genome and genes. Individual as a genomes and whatever vector we have, because one parent will have a multiple vectors. Okay. So that is called genes here. Okay. Now population and generation. What is a population and generation? This also we have to understand. A population is an array of individuals. For example, if the size of the population is 100 and the number of variables in the fitness function is 3, you represent the population by 100 by 3. So if let's say that I have 2 variables and population is 50, so we will have a total population 50 into 2. the column will be always equal to number of variables. Okay, the same individual can appear more than once in the population. So multiple same individuals can have multiple same points. Okay, for example, the individual 2 minus 3 1, in the case of 3 parameters, 3 inputs if I have, can appear in more than one row of the array. Okay, at each iteration, this genetic algorithm performs a series of computations on the current population to produce a new population. Each successive population is called a new generation. So from the parents, we select again the children based on the mutation, crossover or elite. Okay, based on this, we select the children. And there is one more terminology that is called diversity. So in this case, this points blue one which you see, that is more diversified, and this is the less diversified. So diversity is essential to the genetic algorithm because it enables the algorithm to search a larger region of the space. So you see that if it is my points are diversified, my population is diversified, it will search in the more basin, right? The area of these points will be more instead of this. So selection of points, selection of population is also very important. Maybe in the particle swarm case, particle swarm is somehow similar to genetic algorithm actually. So it can be outbound also. So we have to take care of the population as well. Now fitness values and based fitness values. The fitness value of an individual is the value of the fitness function for the individual. Okay, so who will be the best? Any question? Question from my side that who will be the best fit for the next generation? Any idea? As I told that I have an objective function. I have some points. I am giving that points to the objective function. I am getting the some value. So maybe I will have a higher value and lower value. So lower value will be the best fit, or higher value will be the best fit. Okay, so what I want to say, fitness value can be higher, means a parent can be will have a good fit. More healthy. Another can be maybe weak or something like that. So in this case, in this toolbox, the fitness values of an individual is the value of the fitness function for the individual, because the toolbox software finds the minimum of the fitness function. So the best fitness value for a population is the smallest fitness value for any individual. So if you are going to find minima, then best fitness values will be the who is the more weaker, who has a lower value from that objective function. So always weaker will be selected for the next generation to generate the next generation. Okay, if I am working for the maxima to find out the maximum value, because overall we have to minimize the objective function, that is a fitness function, right? So who will be a weaker, he or she, weaker will be a responsible, weaker parents will be responsible to create a next generation. Perfect. To create parents and children now. What are parents and children? To create the next generation, this genetic algorithm selects certain individuals in the current population called parents and uses them to create individuals in the next generation, and some parents will be removed from there, of course, and they are called children. Typically the algorithm is more likely to select parents that have better fitness values. So it means better fitness values means low fitness value. Better fitness value means the value which is coming low, if you are using the MATLAB toolbox in that case. Okay, and how the children will be selected? Maybe a parent can be a children for the next generation, that they are called elite, means it will have the lower fitness value but best fitness. Lower fitness value is the best fitness value actually. Okay, lower fitness function value is the best fitness value. Or cross children means some properties of more than two parents are there. So some properties from the one and some properties from the another will be taken, and this will be a children for the next generation. Or mutation means some modification in the parents, that is called mutation. These are the three ways we use in genetic algorithm. So that's very important to create how it will compare the fitness function to. There are different kind of functions available for that also in MATLAB. How you are going to compare the fitness value, right? So it will work like this. First generation some will be removed, then from the next generation to generation will be removed, and in the final only one point you will get where your function is optimized, right? Okay, mixed integer genetic algorithm. So I have a one example here which I am going to show you. Let me explain the objective of this. Then before that I will show you to demo how genetic algorithm works. Then we'll go for this one. Okay. Okay. So if you are from electrical, then you will understand more better. So what is the objective here? This is a thermistor circuit here which you see, right? This is the thermistor 1 and this is the thermistor 2, and this is the complete thermistor value. And here what we have to optimize, the B point which you see, at B point we have one curve here, voltage with respect to temperature. Okay, at B point somewhere we have a voltage with respect to temperature. So this data I have already, the blue curve which you see in this case. So what I want to do, I have one equation as a voltage with respect to temperature. Okay, so in this case the temperature is T data, fine, and I have a voltage equation for that. Okay, what is Req and what is R3, this R3 equation and R1 equation, and we have separate equations for that, RTH1 and RTH2. We'll discuss that later. Okay, now okay, one thing we got that we have this function as a voltage at this point with respect to temperature, and our objective is to create a mathematical equation to achieve this curve. I want to achieve this curve at this point. So in this case what we can do, whatever this my objective equation is here, we can subtract the original data like we saw in the previous one example, first one in curve fitting. So this is the example of curve fitting. Okay, and what are the parameters? So what we have to optimize basically here, residual error. This is my objective function, subtract the original voltage which we have to achieve here, the data we have, and we have to minimize that. So this is our objective. Now about parameters, what parameter do we have in this case? The parameters which we have to estimate, they are resistance. 6 resistance values are there, but the resistance values are as an integer, because resistance cannot be 100.5 or 100.6. That's why I am saying mixed integer genetic algorithm. Okay, this is a mixed integer genetic algorithm. So before go on this example, I will like to show you to demo, then we will go switch to there. Okay, again. So how the genetic algorithm works and constraint minimization using the genetic algorithm in MATLAB, I am going to show you that. Hybrid scheme in the genetic algorithm, because to enhance the speed, how we can use hybrid scheme in genetic algorithm. This both we are going to discuss. So first of all, we will start from constraint minimization using the genetic algorithm. So I am just switching here in MATLAB. I am just going to open this. So my objective function is this one. This is my fitness function. So you can create a user defined function like this. This is my objective function which you have to minimize. Okay. So I have created as a user defined function here. And here you see that we have two parameters which we have to estimate, x1 and x2. So we will write our equation like this, and we have to optimize this function. This is a fitness function in this case, right? And we have some non-linear constraints available here. So two non-linear constraints are there. First is this complete, means it will be like this, 1.5 plus x plus into y plus x minus y is smaller than equal to 0. First nonlinear equality, and this is the second nonlinear equality. It is a nonlinear equation which you see, x1 is multiplied with x2. So x1 is the x, x2 is the y. So we write in MATLAB like this, x1 into x2 plus 10. This is the second one. So we have to write it is inequality. That's why we have written C is equal to. If it was equality, then we had to write as a C equivalent, and this we have to leave it as a blank like this, because it is inequality, because I know. That's why I don't want equality for that. That's why I left it as a blank. We don't have equality, we left it blank. So we require this C value. So inequalities we can write as a function like this. So function file will be always look like this. It will start from the function percentage sign, which you see here we use to write the comments here. This is the comments. When this function will be executed, MATLAB will not know that what is this. This is for our purpose, that what is this. Okay, and we saw already the function which we have to optimize. Perfect. So now let me open this live script. So here also it is mentioned here, we have to find out the minimum of fx at point x, means what will be a value of x, so fx will be minimized. Okay, so to minimize this, we have provided some non-linear constraints here and some lower bound and upper bound for x1 and x2. This is the solver base. So how to write a solver base, let's discuss. Okay, first thing which we have to do, we have to write as a function. This is the fitness function, and next user defined function will be like this for the inequalities. Now minimization using GA in MATLAB. So first of all, the objective function which we have created as a user defined function, we saw it just before. We have to call it using the function handle at the rate. So now what will happen, this objective function will act as this now. Means this objective, I am giving the handle of this objective function to this name. Now this is the objective function. Okay, so first of all we have to write our objective function and we are calling like this. Now next is we have to define how many number of variables are there. So in this objective function we have two number of variables, x1 and x2, and for the x1 what is the lower bound, 0 is for the x1. So as I was saying you, we have to convert everything as a matrix in the case of solver base. So 0 is lower value for the x1, and again 0 is lower value for x2. Upper bound, 1 is lower value for the x1 and 1 is the higher value for the x1, means x1 will lie between 0 to 1 and x2 will lie between 0 to 30 is the upper bound. And again same way the constraint, means linear inequalities which we have, non-linear inequalities which we have defined, again we are using at the rate, we are giving the access of this inequalities to this. Okay, now very simple way we used to solve this, very simple, just there is a one function in MATLAB that is called GA. Okay, GA objective function means the function which we have to minimize. Objective function is also our fitness function in this case. How many number of variables are there, already we have defined here, right? Let me clear all output first, then I will start execute this again. Okay, and how many number of variables are there, that also we have defined. In this case we are not going to use inequalities which we had here, because we don't have here linear inequalities, right? So here this matrix will be for the linear inequalities, this is for equalities. So we don't have all this, we are leaving it as a blank. Okay, A, B, equivalent, B equivalent matrix, means we don't have inequalities, linear inequalities or equalities, we are leaving it as a blank. We have lower bound, already we have created. Upper bound, already we have created as a matrix. Okay, and here is the constraint, means linear inequalities which we have defined, we have provided in the last one. Once I will learn this, it will be executed and it will give me the value of x1 and x2 and what is the minimum value. So here you see x1 value is this, x2 value is this, and what is the minimum value, means what is the optimized value of my function, that is 1.3573 into 10 to the power 4. So here the mutation function which is available in MATLAB, there are different kind of mutation functions are available. Here it use different that is called mutation adopt feasible algorithm to convert a mutation for that. So if you use this as a default MATLAB, means not as a default it use Gaussian or something like that. So it is written GA function change the mutation function to this. The default mutation function is use this Gaussian number generator, mutation Gaussian. This is the default one, and this Gaussian will not identify the nonlinear inequalities in some cases. Means it will not consider that. So in that case we can change the different mutation functions also. How to change that? That also we are going to discuss. Before that, let me show you what more things are available in GA. Just simply I am going to select there and just I am going here in help and just simply open the help browser, and here are the syntax, and if I go in name value pair, here if I scroll it below, this is a step-by-step process and with some examples here it is given, right? And what kind of arguments will be upper bound, lower bound, how we can define in this document, everything is given here. Perfect. Okay, now what we are going to do in this case, next is with some constraint minimization. How we can do a constraint minimization in GA operators. So what I am going to do, as a before I told that it default it take mutation Gaussian, but there is a issue with that it doesn't detect nonlinear inequalities. So we can change that mutation function like this. Always we have one function here that is called optim options to change the algorithm, to change the solver functions, to display the output. We use optim options. Okay, so optim option is generic. It is used to define the options for any kind of optimization in MATLAB. So let's say I want to know what kind of options are available for GA. Okay, so simply I will just select this, and from here I am going to help. I will open in the help browser. As I told, this optim option is generic. I want to know for the GA only. Just I am going to search where is the GA. So somewhere below it will be given. Oh, okay. Just wait a minute. So here you see that we got GA options, right? If I am using genetic algorithm, so what options we can use? Means we can change the how we are going mutate it, how we are going to use crossover, or how we are going to choose elite. So this kind of options we can provide in the options. When I click here in the options, like constraint tolerance. So here is the explanation also. What is the constraint tolerance also, right? Determines the feasibility with respect to non-linear constraints. So for the feasibility, for the non-linear constraints, we can define the constraint tolerance also, right? And what kind of crossover function are you going to use? I mean, I already told how the previous generation will be converted or present generation will be converted as a next generation. What kind of crossover functions are you going to use? It's given here, right? And there is a crossover fractions also. The fraction of the population at the next generation means how many will be converted, means from the main population, at what fraction, at what extent they will go to the next generation. So this also we can define it here. So all these options are available here. Okay. Now more in genetic algorithm I will like to tell. Just you can create a shortcuts also of any document here. Just I am just like I have added here. Just 1 minute. And here is the explanation. Whatever I am explaining you, it is already inbuilt in the MATLAB. What is initial population, create the generation, mutation and crossover, how we are going to select, that is given here, right? So this everything is here available. And stopping condition of the algorithm, maximum generations, we can provide the maximum generation. After that it will stop, maximum stall time also we can give. These are the some stopping criteria also which we can provide in the option file. So once we have created option, now I am going to change this mutation, right? So in this case, again I am going to use GA objective function. How many number of variables are there? We don't have linear equalities or inequalities. We left it as a blank. Lower bound, upper bound we have. We have constraint function option there. Just I am going to execute. So you see that in first one it is a pretty similar, same thing we are getting in this case, right? Same value we are getting in this case. Okay, now in the same GA, if I have to add some kind of plots, so again we will use this optim option to plot. So when you go in the help, you can check what kind of plots are there. So in this case we are using one GA plot based fit. One plot will be for the based fit, and there is another plot also, maximum constraints plot, that is called GA maximum, which plot the maximum constant violation of non-linear constraints at every generation. What is the violation? Because let's say that I have issues that I don't know that it is identifying non-linear constraints or not. So what is the violation plot of that? That also we can plot. So simply option, optim option, and the previous option we are using there, which we have defined above, and plot functions. We are going to best fit plot and this maximum constraint violation plot. Once we have defined this, modified this option and displayed the iterations also. GA objective function, number of variables, and whatever constraints we don't have, left it as a blank. Then the same thing, everything, right? In the last one we will provide the option. So once I execute this, I can check the graph also like this. This is the fitness value. Fitness value have to be lower in this case, right? This is the constant violation graph, and we can visualize this graph also. And not only the graphs we can visualize here iterations also. In the first generation function count, second generation, third generation, until fourth generation. It ran for the fourth generation only. And this is a based fit. This is the function. For at every generation, what is the objective function or what is the fitting function, based fit function values, right? Maximum constraints violation. Star generations are there, right? So we can check the graphs also like this. And in this case, further what we can do, we can give some start points as a population. So in this case, start point is 0.5 and 0.5, means some start points also we can provide like this. So what we can do, one thing I will like to tell you, once we create the option, this option will be also as a structure created. Let me show you. Structure means as a system object. So when I run this, and this is the function, like you see here, we have an initial population matrix. If I have to provide the initial population matrix also, control V dot initial population matrix. Initial population matrix here we can provide as well, right? So initial different options are there. Initial population range also you can provide. What will the range? What will the matrix? So always remember, when we provide the matrix, number of generations can be multiple population, but number of population is rows, and number of variables will be as a columns. Okay. So here in this case we are going to provide initial population matrix only just two values, 0.5 and 0.5 here, and same thing is remaining things are same. And we will see the difference in the graph. How to provide this value? If I know that my parameter value will be somewhere here, in that case only you are going to provide like this. Fine. So this is the way, some modification how we can do in the genetic algorithm. Okay. Second example demo which I am going to show you, what is the benefit of using hybrid scheme in the genetic algorithm. Okay, I am just switching here, and just I am hybrid of scheme of the GA. Okay, this is a equation which I have, that is a Rosenbrock equation. This Rosenbrock equation will look like this. This is a Rosenbrock equation. We have to optimize this equation, means we have to find out the minimum value in this figure which we see. So if you have to plot the objective function, just simply you can provide the plot objective, and this is my as a user defined function, provide the minimum and maximum constraints like this, minimum and maximum boundary conditions, and you can plot it also in a single line. Okay, this is my objective function. I am going to use the genetic algorithm the same way, and I am going to plot the base fit also, and stopping criteria also I am going to plot. So both plot I am going to do. So I will provide this in a optim function, optim option, right? GA, this is my fitness function, that is that equation which we saw here, this one, right? Rosenbrock. Okay, number of variables we have to define, two variables we are taking, and here you see we are not going to provide inequalities or inequalities. Everything is blank, just option we are going to provide to plot it. Perfect. So I am going to run this. So you see here, this is the fitness value, it has to be minimized for every iteration. Now you see that it is becoming lower, so it's going good by this graph. And total generations and stall generation. So stall generation means that's the maximum criteria based on the generation, that how much it will generate. So there is a total maximum criteria, and total generation is doing here. So this stall will be always maximum in this case, right? So this is the total generation which has done here in this, in this case as a percentage, right? And this figure is also here, and this is the fitness value which we see, and this is the generation here which we see, right? And what is the optimized value? 0.3454. This is the x1, this is the x2, and this is the function evaluation. But there is a issue in this. We know that my global optimum value is at 1 and 1, right? So what we can do, we can provide some we can do some modification like which we have done in earlier. Means what will be a mutation function and what will be a crossover function. We can change that things in option, right? So I know in this case x1 is 1, x2 is also 1, and we'll have the value on that minimum value in this case, right? So how to provide a hybrid function and what is the benefit of hybrid function, we will like to discuss in this case. So hybrid function we can provide like this. First thing, what it will do, it will take the less iterations. So hybrid function is what, that is a local maxima minima functions is there, that is called a hybrid function. So what global optimization will do, means what genetic algorithm will do, it will find out the local region. Okay, genetic algorithm will find out the local region, and then genetic algorithm will be stopped working. After that, this hybrid function will start working. So this kind of functions are sorry, this kind of functions are already available in MATLAB in the optimization toolbox at Munich. That is this is used to find out the local maximum minimum. So after finding the local region, we are using local function to find out that. So here you see again in the opti function we are calling this local minimum. Sorry, for this local optimization function, and we are again plotting how many function evolution it took, right? And further this is my hybrid function which we created here, and again optim option, and this option we are taking, and what is the hybrid function, we are calling that hybrid function like this, right? This is the hybrid function which we are running. So in optim option, previous option, if you have to retain it, just write as an option whatever previous option which we have defined above, right? Now let's execute this, and in this case function counts will be also less, iterations will be also less, generation of population will be also less, time taking will be low in this case. And in this case, let's see what output we are getting. Local minimum found, means after genetic algorithm, hybrid function is used and local minimum is found. The base value it is showing you here, and what is the mean value of every iterations, or you may say every generation, and you see here generation is also very less, right? And previous one, when we didn't use a hybrid function, generation is more, right? And let's see what is the output of x1 and x2. perfectly after adding the hybrid function, as I knew that x1 is 1 and x2 is 1 for the optimized solution, and we got it that with the less generation in the less time and less iterations, right? So it's very important sometimes if you want to use the hybrid function, and use the hybrid function as well. Meanwhile, any question if you want to ask, you can write in a chat box. Any doubt, any questions, you can write it in a chat box. Okay, now we are going for now that main objective function which we are discussing about, that electrical circuit, this one, right? So let me explain this, what we are going to do here. Okay, I have one curve. This is a curve fitting problem, first thing, and this is a mixed integers GA which I am talking about. Okay, so here what we are doing, this is my equation, voltage equation with respect to time. This is my voltage equation with respect to time, which we have to optimize. To get this curve, what we can do in this voltage, we can minus the curve value in this voltage, the voltage original which I have, which I want. Means for the voltage value which I am going to generate the equation, we can subtract it like previously which we have did. So we have to minimize the residual, right, error. So as much as the error is near to 0, means we are getting the perfect fit. That's all which we have to do. So let me switch here. So you can, in MATLAB, you can call one function in other functions as well. Okay. So first of all, let me clear. I have created a shortcut here to clear command window and everything. So there is an option here. You can create your favorites also. You can write a MATLAB scripts here. So it will be appeared here. When you click, it will be cleared everything. Okay. So let me show you that example. So it is not actually 1 hour or 2 hour kind of things. It takes time to do all these things. So just I am showing you a demo how to do this. Just 1 minute. Okay. You see that multiple functions I have created, right? And this is a thermistor one example, and here also you see that multiple functions are there, right? Like if I click on the voltage curve, so what we have to do, as I told, my resistance are integers, so we have to create our problem in a such way. See, input I am giving, what I am optimizing basically here, index of the resistance. Okay, 70 resistance are I have, index of the resistance we are optimizing. So here my input X will be as an index of the resistance, and this index we are calling as a resistance y1, y2, y3, and these are the constants, beta value, this value, thyristor value, and this beta. These are the constant things. Okay, the first thing, and see in this function we are calling one more function that is called temperature curve, compare curve. Temperature voltage comparison curve. I am going to open this, and here you see that by this final equation is this, means for this I want to get the 6 resistance values. What will be the resistance values for that? Okay, this is the equation. So you can write your equation like this, whatever constants are there, define it, some sub functions you can define, and you can substitute in the main function. And again there is one more main function that is called the voltage. Fine, perfect. So what we will do in this case, we will do a indexing of the resistance. My input will be index of the resistance, and that from that index we are calling the resistance from vector, and that resistance is applied on my objective function during optimization. So maximum iterations will be there. Okay, now the main script file I am going to open. So just simply I am going to open it as a live script. So if you have a script file, this is a script file where you cannot visualize the figure and numeric value. To visualize the figure and numeric value in a script file, you have to open a different window to visualize. A different window will be open. So in live script you can visualize the same. So you can create a script file as a live script. Just right click and open as a live script. So you see that as a live script it is created. right? So in this case, this is the my curve. Here I have a temperature and I have a voltage data here, and I am going to plot it. So this is the my plot, and for this we have to create a optimized mathematical equation. At what point? At this point I want that my voltage will vary with respect to temperature like this. That's what I want here, right? Okay, I am going to load resistance and all the constant parameters, means the parameters which you have to optimize and the parameters which we don't have to optimize. So these are the resistance. You see that total 70 resistance we have. And why we are using the mixed integer? Because resistance values are integers, as an integer. Because let's say I don't have a 500 ohm resistance. From where will I buy? Even if it doesn't exist in the market, and I have to create that thyristor circuit, then what will I do? We will use optimization in this case. Whatever combination of resistance I have, with that combination I am going to select the best resistance to optimize my the objective, right? So we have this. So from here it will call as an index number 1, 6 resistance I want from this combination. Okay, and remaining parameters are constants, means that we don't need to optimize that. So I'm switching here. I have loaded .mat file also. Okay, so it is just a display of some resistance which we have, total 70 resistance values which we have. Okay, what I am going to do, this is my voltage curve, means the function which I have to optimize here. So let me open this. Just wait a minute. What is this voltage curve? This is a simple plot here, and there is one more function is available there. Just 1 minute, let me show you that function also. Let me open this, and this is the voltage curve, and this is temperature curve, and one more function we have here, this is the objective function which we have. So see, this is the objective function which what we are doing here. F, as we know, f is the original function which we have to optimize. We are subtracting the original voltage, means this is my function which we have to optimize. Whatever value we are getting, I want that residual will be 0 if my whatever my simulated output is there here, and whatever original output is there. If I have to minimize the error, means this residual have to be 0, right? So same thing we are doing here. So we are just calling the function, one function in another function, but this is my main objective here in this case. Okay, okay, now we have, let's say that some random resistance, 6 random resistance I am going to take, and I am going to plot this. These values are the constant in that mathematical equation. So let me plot that, and don't forget to give a command hold off also after plotting the same thing. So you see that randomly if I choose, manually if I choose, this curve which I have to fit it, and simulated curve is coming this one here. This is a random resistance I have taken here from here, right? Okay, now next we are going to define for the resistance what will be the lower index value and what will be the upper index value. So you see here what we have done here, from 1 to 4 we can choose any resistance, but the last two resistance will be from index number 1 to 9 only. So this kind of bounding conditions you can define like this, means whatever indexing of resistance I have here, if I switch here the resistance which I have, last two resistance I want from 1 to 9 only, and remaining resistance can be anything from 1 to 70. So in this case, just we have defined here what is the lower and upper bound. And now one thing is very important, as I told, how many parameters are integers. So we can define like this. In my case, my all parameters are integer, so 1 to 6. Let's say last two resistance were only integers, then 5 to 6, 5 colon 6. So two values are integers. In case all 1 to 6, so 1 to 6 will be as an integer. So int con, in int con variable I have defined that also. Okay. So I executed this one and this one. Now this is a custom plot. So depends on you, you can use inbuilt function. So it will show you at every population generation what the curve is coming. So this kind of curves you can create or you can use inbuilt from the MATLAB. Now this is the older way to define the optimization option. This is GA optimized function, but this will be removed in the future. So you use optim option to define the function. Whatever crossover fraction will be, means how many from parents will be selected in the next generation for the children, what will be the fraction of that, what will be population size. So you see in this case population size is 100, right? So what will be a matrix? 100 into 6, because 6 parameters I have, right? And star generations, total generation, plot functions, what we are going to give. So this is our option in this case, right? And now we are going to use ZA to solve that. Here we will get the output, means all 6 resistance values, and here we will get the optimized voltage value, that is a residual in this case because we are subtracting that. And this is a GA, and this objective function we are going to optimize. Objective function already I showed you here, this one, right? So why I am saying this is my objective function, this is the objective function actually. This is a just multiplication of residual, because G is defined here. Whatever is defined here as a output and what is here the equation as a equation, that will become an objective function. So this is my objective function, right? Here J is defined as output here. Fine. So I am switching here, and simply I am going to run, and here you can see it every penalty values in this case, and here you can see the fitting value, how it's fitting at every population generation, I mean whatever next generation to next iteration to next iterations, right? So penalty value have to be less, and this kind of plot functions you can create as a user defined function also, or you can use inbuilt which is already in MATLAB, that what kind of things are you going to plot. So now you see that it's running, and here it is almost this fit is given here, right? So that's all which we had to do, and it is still it is fitting here. Let me zoom it. Still it is running here, and to more I want to execute this problem in a less time. So we can add a hybrid function there. Some local function we can add it there, right, as a hybrid function in the option file. Perfect. So it will be done. So you see penalty value, this is showing the lower, and this you see the almost this is fitted. So we got the resistance values also. R1 will be this, R2 will be this, R3, R4, and these are the some okay, we have this thyristor values also here. Okay, so 6 total resistance we have, which we have optimized here. 4 resistance and 2 thyristor values, right? So that's all. So this is the way. If you have any questions, you can write. Otherwise I will switch on PSO.